Hey guys, Miss Marflack here. We're going to continue with our Algebra 2 review. The last time we met over video, we talked about interval notation, set builder notation, and then we had that graph to kind of visualize the two notations. As we're going along through this Algebra 2 review, we're pretty much doing a topic a day with the assumption that we've seen this before in a previous class, and we're really just working on mastery here. Now today we're still in this topic of functions because that's what our entire packet is about. We're going to be taking a look at a very specific type of function, and that is our piecewise functions. Now as we go on in marking period 4 towards the end, we are going to do an introduction to limits, and we're going to see that we're going to analyze limits, and most of them are going to be piecewise functions. So we're going to review the different types of functions. We're going to review how to graph a piecewise function, and then briefly how to analyze it just with the domain and range, and then our next lesson we'll work on more with analyzing with intervals of increasing, decreasing, and constant. All right, hopefully that gave you enough time to set up your notebook here, and you can see that I have graphing piecewise functions, and the first thing is, well, what's a piecewise function? And that's going to be defined as a function that has two or more pieces or two or more equations, and then they're going to be over this specified domain. So on one side of our piecewise function, we're going to have what the equation is, and then on the other side, we're going to have our domain, our set of x values. Now we're going to review some of the types of functions that we should have seen in Algebra 2, and we're going to start off here with our constant function. And there's that f of x notation, which is equal to our y. And then when we have f of x is equal to c, where c is any number, any constant, such as 3 or 4 or 1 or -2, you're going to see that you're going to have that horizontal line. So that's our first type of function. Another type of function you should have seen in Algebra 2 is your linear function. You did a lot of work with this in Algebra 1 and Algebra 2, and that's your f of x is equal to x to the first power. So that linear refers to the degree here. And then that usually here with, mx plus b, we have a slope of 1, and our y-intercept is at 0, and then there's that positive slope for our parent function. After linear, we just kind of keep going up with the degrees, and our next function that we should be very comfortable with is our quadratic, and that's our f of x is equal to x to the second degree. And our quadratic also sits at the origin 0, 0, and kind of has that curvy shape. You have that happy parabola opening upwards. Those are the first three, and then we're going to move on. We're going to take a look at a few more, keeping it going with adding a power to the degree. Our next would be our cubic. We usually stop after here. There are polynomials of higher degree, 4, 5, 6. We usually just stop at the cubic, and our parent function also goes through the 0, 0, and we have this point of inflection there, and then we have our arrows on both ends. All right, and then our inverse of our quadratic is our square root function, and our square root function we can model here as f of x is equal to square root of x, and then that's undefined where x is less than 0, so we have that point at 0, 0, and we're only taking that domain for the positive values. All right, now it's time for our inverse of our cubic function, and that is our cube root. And our cube root function, we can model f of x is equal to cube root of x. And it looks very similar to our cubic function, but it's laying down. And here it is, still going through that point of inflection and still having that positive slope there. All right, I did try to squeeze in 4 coordinate planes here, and I was successful. Now we're going to take a look at our absolute value function, absolute value. And that is our f of x is equal to the absolute value of x. Keeping in mind, absolute value is the distance away from 0. And then here we are, we have that pointy V shape, pointy V. Next, we're going to call this our reciprocal function. Now, you could refer to it as your rational function, inverse function, but I use reciprocal. And that's where we have those two branches and those two asymptotes. Squeezing it in here, exponential, I'm going to abbreviate because I'm just kind of running out of room here, and that's f of x is equal to b to the x, and we usually denote this with a growth graph. We could also have the exponential going in the other direction with our decay graph, and then the last one you should have seen in Algebra 2 was your log function, and that is log base b of x. And that is our inverse of our exponential function, and then here it is. Okay. So, there are a lot more, functions than what we just have seen on the paper here. You should have, maybe somewhere seen your step function, your greatest integer function. You could see, polynomials of any higher degree, things like that. But for the most part, our pieces here in our piecewise functions are going to be functions that we're familiar with. Now, you don't need to memorize these at all. You could still graph your piecewise functions without knowing any of this. When in doubt, when you're graphing a function, you really just need a table of values. However, if you know what your constant, linear, quadratic, cubic, cube root, square root, absolute value, reciprocal, exponential, and log function looks like, it will save you a lot of time, because then you don't have to do a table of values, and you can use your knowledge or different characteristics that you know of each function. For the most part, you're going to see here the constant function, the linear, the quadratic. I don't think I saw a cubic in the packet. I don't think I saw a square root or even a cube root. Definitely saw an absolute value. So we're really going to be focusing on these 4 here, and that's what we're going to be seeing in the packet. All right, this would be a good time to pause the video. Make sure you have everything down on this page. Just one last scan here. Here is our little blurb we started with. Here's 6 graphs, and then here are the last 4 graphs. All right, moving on to the packet. The last time we met, we did the interval notation and we kind of bounced around a bit in the packet. Unfortunately, we are going to be doing the same thing here. That is because if we were in school, instead of doing the remote learning, I would have taught interval notation and piecewise functions in the same day. That's why they're kind of mixed in here on the packet. All right, the last time we met, we filled in this part on page 2, and now we're going to be filling in example 5 on page 2. So that's where everybody should be, example 5 on page 2. Now, if you don't have the packet printed out, no worries, just do it in your notebook for right now. All right, our goal here is to graph this piecewise function, and then we're going to determine the domain and range, and we're going to write that domain and range in interval notation. Now we have these different pieces here. F of x, that's our y, is equal to 1, 2 plus x, and then 2x, and then here are our conditionals, and there's our specified domain there in inequality notation. Now I'm going to do it 2 ways. I'm going to start off by showing us the table of values, and then I can help talk people through who do not want to use a table of values. All right, but first we're going to start off with this first piece here, and I always like to put in, what kind of circles I'm going to be using off to the right. I can see that this inequality is inclusive. The one side of this inequality is exclusive, the other side is inclusive, and then this inequality here is exclusive, and there's that open circle. All right, we're going to start off with our function that just has our 1. We're going to do our table of values here for x and y. All right, I'm starting off my table here at x is equal to -2. And then x can be any value less than -2. So I could be -3, I could be -4, and so on and so on. All right, and then no matter what I plug in for x, I'm always going to get out a 1 for y. And there's my constant function there, constant. All right, our next piece here, 2 plus x. We're going to do our table of values, and I'm starting off my table at -2. Now, even though this is not inclusive of -2, I still have to graph this point. Just when I graph it, it's going to be an open circle. When I plug the -2 into the function and I evaluate, I get out a y of 0. Now, I know this is a linear equation. It's switched around here, but here is my intercept on the y-axis, and my slope is 1. Since I know it's a straight line, I do not need to do, -1, 0, 1, 2, and 3. All right, since I know it's a straight line, I could just use the endpoints. So I have that -2 there, and then I'm going to plug in my other endpoint, which is 3. And then 2 plus 3 is 5. And then those are my 2 endpoints for the line. And then here's 2x. I know that that is another linear equation. So I just need the endpoint. The only endpoint I have is x is 3, and I plug 3 and I get 6. And I could do one more point just so that I have that arrow pointing, and we'll do, 4 is greater than 3, and we plug that in, we get 8. Now I've highlighted here our axes because it was just really, really difficult for me to see, but here's my first piece. It is a constant. I'm filled in circle at x is -2. So at -2, my y value is 1 and I have a filled in circle. And then that holds true that 1 for any x value less than the -2. So we're going to have that line going out to the left with an arrow on it. All right, and then now we're working on this next piece. My first point is going to be an open circle. When I plug -2 in, I got -2, 0. That's my open circle. And then it's a linear equation, with a slope of 1, so I can just count up 1 over 1, up 1 over 1, up 1 over 1, until I hit the 3, 5. So here we are, 1, 2, 3, 1, 2, 3, 4, 5. And then if you don't believe me, here's that slope of 1, 1, 1, 1, 1. There I am. And I'm just going to turn the page here so I can put that straight line in there. Okay. And then now for our last piece, x is greater than 3, and it's also a linear equation. Our first point is at 3, 6, so there we are, 3, 6, and our first point is an open circle. And then I have a slope of 2 now, so I can go up 2 over 1, and there's my next point. And then you could see that that point will be at 4, 8. And then I have no upper bound on the x. It's just greater than 3. It could be 100, it could be 1,000,000, it could be 10 million. So we're going to have this arrow pointing up. Arrow pointing up. All right, so I was able to do this. You could do most of it without using the table of values. You can, plug in the points and do a lot of these things in your head, also just knowing the shape of the function. All right, now we're going to take a look at our domain. So now we're done with the graphing. Now we're analyzing this function here. And our domain is all of our x value that our function is defined on. Now, when I'm looking at these x values, they're coming from -infinity. All right, my domain is starting at -infinity. And I'm going all the way up, and then I think I'm going to have a break at -2, but then this graph picks me up, and I'm defined at, -2.01, and then -1.99, I pick up on this graph. All right, and then I'm defined all the way here until what point is at 3. And then I think I'm going to have a break, but then I'm also defined at 3.1. This graph picks me up all the way to 4 and then all the way to infinity. So I can model that with my interval notation, which I think is a little easier to use. That's what we're asked to do in the directions. So this is our answer, but Ms. Marflack's also going to model it with that set builder notation. So we can also have here all values of x such that x is an element of the real number system. All right, and then now looking at those y values for the range, my lowest point on this y-axis is here at 0. That's my lowest point on the y-axis, and I'm not filled in there, so I'm going to have an open parentheses because I'm not inclusive. And then I go all the way up, I'm defined at 0, 1, 2, 3, 4, and then my graph stops here at 5. All right, and when my graph stops, it's a filled in circle. So I'm defined at 5, but I'm not defined at 5.1, 5.2, 5.6, 5.7, but then my graph picks up again at 6, and then it goes all the way up into infinity. Now notice how the 6 is not inclusive because we do have an open circle here. And then I can also model this with my set builder notation, just kind of doing this for extra practice. All values of y such that y can be between 0 and 5, exclusive of 0, inclusive of 5, or we can have this inequality here where y is greater than 6. All right, then you can see that's a little longer to write, and this is where the interval notation is a little helpful. Good time to pause the video, make sure that you have all this down because we're moving on to our next example. All right, our next example is going to be on page, page 3. All right, so everything on page 2 is done now between this video and the last one. And then on page 3, we did the top part together. And now we're going to be taking a look at the bottom again on page 3, and that's going to be number 10. Number 10. All right, here we are. It's actually really similar to the last example. I did say we would be focusing on that linear, constant, quadratic, and absolute value. And then we're going to see that again here. So I'm looking at these 3 pieces. I have a constant, a linear, and a linear. So if you're feeling comfortable graphing, just go straight to graphing. Those of you who are not comfortable with using the shape of the function and your knowledge of the function, go ahead and do that table of values. I like to put in our circles here. I have inclusive, inclusive, I have exclusive, inclusive, exclusive, inclusive, and then that's going to help me with kind of figuring out my endpoints there. All right, our first point here is going to be a -2, and then my other endpoint is going to be a 0. I don't have to do all the values in between because I know how the function reacts. It is just a straight horizontal line. Looking at that next piece there, -3x, I'm going to start with my first endpoint. That's going to be an open circle. I plug it in, and I'm also going to get out a 0 here. And then I'm going to take my other endpoint, which is 2, I plug it in, and I'm going to get out a -6. I don't have to pick the values in between because I know how the function reacts, so just pick those endpoints there. All right, same thing here with that 2x. All right, just picking those endpoints. My first endpoint is 2. I get out a 4, and my other endpoint's a 4, and I get out an 8. All right, and then now it's time to graph from -2. So here I'm at -2. I have a y value of -1, and I'm inclusive. And that's all the way from -2 to the x value of 0. My y values are -1, and there's that first piece there. All right, now taking a look at that second piece, I have a point at 0, 0, and it's an open circle. And then it's a linear equation with that negative slope, so I know I'm going to have this downward slope here. My next point is going to be at 2, -2, 4, 6. And that is a filled-in circle. So I graph this point, open circle, and I graph this point. And then there's that straight, trying to make it straight. Mine's not that perfect, but there's that straight linear equation. All right, and then now we have another linear equation from 2 to 4. So here I'm at 2, and then my y value is 4, so 2, 4, and I have a filled-in circle. Ooh, no, I have an open circle. All right, so see, I just double-checked back there that my first point is supposed to be an open circle. And then my next x value, or my other endpoint, is going to be at 4, 8. So we're going to graph that here, 2, 4, 2, 4, 2, 4. All right, and then maybe not using the table of values, you could have, just graph these pieces from your knowledge. You could start at one endpoint. If I want to graph, for example, this one, I could have started here at the 2, plug it in, I get 4, and then I could go, up 2 over 1, use that slope, up 2 over 1, use that slope. Same thing here, write 1 down 3, use that slope, write 1 down 3, and then there's my other point. All right, now it's time for our domain and range. First, taking a look at those x values. My lowest x value on the left-hand side is -2, and it is inclusive. All right, and then I have -1, I have 0, I have a point at x equals 1, 2, 3, 4, all the way until, let's see here, 2, 4, and then 4 is my last x value, and that is also inclusive there. Or I could have written it in that set builder notation. Now the directions aren't specifying which way to write them, and that's all values of x such that x is between -2 and 4, and it is inclusive of both. All right, now it's time for range. We're going to pick that lowest point on the y-axis, and that's that point here at -6, and we're inclusive of the -6. And then we go all the way up on the y-axis, and then our point, we have a jump in the graph here at 0. All right, and we're not inclusive of the 0. We have an open circle. And then next y value that we pick up at 1, 2, 3, and that's going to be at 4. And then we go all the way up to the y value of 8. All right, 4 is an open circle, and then 8 is a filled-in circle. All right, and then this could be a little hard, to model with the set builder notation. I'm going to do it anyway, because now we have these 2 intervals here. And that's going to be all values of y such that y is between -6 and 0, or our y can be between 4 and 8. And you can see that's a little bit longer to write there. All right, there's number 10. Good time to stop the video. Try to stay alive here, and we're gonna do one more. All right, so that's page 3. The next one we're gonna take a look at is on page 5. Page 4 is gonna be our homework. Page 5 will also be our homework, and I'm gonna do one example from page 5. That's going to be number 11. Yay, we have an absolute value, so we're not just working now with the linear equations and the constants. So spicing things up a bit. All right, once again, we're on page 5, number 11. All right, we're going to start with that table of values. We know we're going to have constant, we're going to have that absolute value, and constant. So here I am for my constant graph. X values are less than or equal to -6. So I'm starting at -6, and then I can pick values less than that, -7, -8, so on. But I know it's just a straight horizontal line, and I go and I plug it in, and my Y values will always be 6. And that's going to be a filled in circle. All right, our next piece here, we have the absolute value of X. We have to know how that function kind of looks because it starts here at -6, and when I plug it in, I get out a +6, but we have this inflection point at 0, so I do need to put that V there, and I'm plugging in 0, I get out 0, and then my other endpoint is 6, I'm plugging that in, and I get out a 6, and then I'm going to see that these two endpoints are going to be open circle, and then for our last piece here, we have another constant at 6, and those are values of X greater than 6, so I got 6, 7, 8, 9, and so on, and whenever I plug in those X values, I always get out a Y value of 6. And then that's also going to be an open circle here. All right, so once again, when X is less than -6, so here I am, 2, 4, 6, 2, 4, 6, and it's a filled in circle, and all the values less than that are also 6. See, I didn't need a table of values for that. You could double check with it, but you could graph that piece without a table of values. And then now you know all the values between -6 and 6, so this is going to be an open circle. But since the open circle is laying on top of the closed circle, I could just leave that closed circle there. And then I'm going to have a point here at 0, 0, and then another point at 2, 2, 4, 6, 2, 4, 6. And I know that this is my absolute value graph without any transformations, so I know it has this V shape. All right, so I was able to do that also, maybe without using a table of values, just picking some key points. And this side is an open circle. All right, once again, the other side is an open circle, but because I have that filled in circle there, I could just leave it. If you don't like that, you can also put an open circle around it. I've seen some students do that. All right, and then now for that last piece, X is, for all the values where X is greater than 6, so that's over here, all the values greater than 6, our Y values are equal to 6, and then we still have that open circle there at 6, 6. All right, now it's time for our domain and range, and our domain is going to start at -infinity, our lowest X value. We go all the way to here at -6. I'm defined at -6 for my first piece, all the way to 6, and I'm undefined at 6. So I have to skip 6 in my interval from -infinity to +infinity. Now this is a little easier to write in the set builder notation, and that's all values of X such that X just can't be equal to 6. All right, we could see that break in the domain here. Well, any value less than -6, I can equal -6. Any value between -6 and 6, but I can't be 6 here in either inequality. All right, now it's time for our range, and our lowest Y value here is 0. All right, and then our highest Y value is 6. Now, even though we're undefined here at 6, I do have Y values all the way here at 6 and all the way here at 6, so I can include the 6. And that's all values of Y such that, Y is between 0 and 6, and it can be inclusive. All right, so like I said, this is Algebra 2 review, so we kind of went, quick. We only looked at 3 or 4 different types of pieces here. You can see a lot more. We didn't see a quadratic, we didn't see certain things like that. I'll be putting up some more videos, and we'll also see a little bit more of domain and range. All right, your homework I'm going to post on Google Classroom is going to be out of the packet. If you don't have a printer, that is okay, and it's going to be finishing up pages 4 and 5. All right, thanks for sticking around. Email me if you have any questions.